Okay, this is the P1 paper from October 2023. It's question number 7, and this is a question where we're going to be working out an equation of a normal, which is out of the differentiation chapter, and we're also going to be using integration to find fx if we already know what f dash x is. So let's have a look at the question and get started. It tells me I've got this curve c, y equals fx, but it gives me the gradient function f dash x here, which is given by this complicated fraction that I've got. It says the point 4 minus 1 lies on c. Can we find the value of the gradient of c at p? So at that point there, yeah, absolutely I can. So A part 1. F dash x is given by that function that we just had, 4x squared plus 10 minus 7x to the half, all divided by 4x to the half, and then they want the gradient at p. So the gradient at p is just f dash x, but at the point, and it's the point 4, 1, so 4 minus 1, sorry. So what we actually want is just f dash 4. So f dash 4 is 4 lots of 4 squared plus 10 minus 7 lots of 4 to the half, all divided by 4 lots of 4 to the half, and you can put all that into the calculator and it will just give you a function. Be aware of the fact that, for example, 4 to the half is just going to be equal to 2, 4 squared obviously is 16, but anyway, just stick it all in and it works out to be equal to 15 over 2. So that is the value of the gradient at p because it's f dash x at x equals 4. So A part 1 done. A part 2 wants us to find the equation of the normal. So if I want the equation of the normal, this is the gradient of the tangent. The gradient of the normal then, remember normals are perpendicular to tangents, so the gradient of that one is minus 1 over this gradient. So minus 1 over that, the quickest way of doing that is to just turn it upside down and make it a negative. The gradient of the normal then is going to be minus 2 over 15, and so I've got all the information I need to work out the equation of the normal now. You should have done lots of work on this. Finding the equation of a straight line is y minus y1 equals mx minus x1. If we have the point x1, y1 on the line, and we do, that's p, so that's 4 minus 1, and if we have the gradient, and we want the equation of the normal, so in that case the gradient is minus 2 over 15. So if you stick all of that into the function here, so y minus minus 1, it's going to be y plus 1, minus 2 over 15, x minus 4, and then did they say how they wanted it? Yes, they did. So they said they wanted it in this format here. So at this stage, multiply everything by 15. I'm going to get 15y plus 15 is equal to minus 2 x minus 4, and then just tidy this all up. That's going to give me 15y plus 15 equals minus 2x plus 8. Just be careful when we're tidying this all up. I'm going to say that's 2x plus 15y, and then 15 minus 8 is going to give me plus 7 equals 0. So I've got that in the format desired. So we've done A part 2. B then is finding the integral of fx. So we're going to be integrating this function here, and remember we know x is 4 and y is minus 1, so I'll be able to get rid of my constant once I've done that, but let's take a bit of time over this because it's quite a complicated function that we've got. So we've got f dash x is equal to that function that we had before, 4x squared plus 10 minus 7x to the half, all divided by 4x to the half. So before I start integrating it, I'm just going to tidy this up. I can't integrate it like it is at the moment. So that's the same as, let's divide everything, let's split it up into the various parts. 4x squared over 4x to the half plus 10 over 4x to the half. So I'm just doing this really slowly. You might take less steps than me, but as long as you get the answer right. Don't mind how many steps you take here. So the first one is to just break it down into all those individual ones, so I can then say, well, the 4's cancel, and then x squared divided by x to the half. Take away the powers is just that. This is going to be 5 over 2, and then I'm not going to put it over x to the half. I'm going to call it x to the minus a half, because remember I want to integrate this in a minute. So I want it all in the right sort of way to be able to integrate it, which is to have powers. Sorry, I'm just looking at the last term then. The x to the halves cancel, so I'm just going to get 7 over 4 there. So we can now say those are all f dash x, so that's f dash x and f dash x. I haven't done any integrating now, up until this point, sorry. So fx is going to be the integral of this thing. So x to the 3 over 2 plus 5 over 2, x to the minus a half, minus 7 over 4, all with respect to x. And so integrating this, remember, add 1 onto the power, divide by the new power. So adding 1 onto the power makes that. Dividing by the new power, I would say 2/5 there, but I'm quite happy to do it slowly and have it as divided by 5 over 2. Same with the next one, add 1 onto the power, makes x to the half. Divided by the new power is 5 over 2. And again, divide by the half there. And then obviously minus, that's just 7x over 4 plus our constant. So that is fx, but we do know, I'm going to tidy it up, and then also we'll know that x is 4 and y is equal to minus 1. Let's just tidy this up first of all though. So fx is, that's better to be written down as 2/5 x to the 5 over 2. This works out to be 5x to the half, and then 7 over 4x plus c. So we know x equals 4, y equals minus 1, or a better way of writing that down is to say f4 equals minus 1, but either way we're going to say minus 1 is equal to 2/5 4 to the 5 over 2 plus 5 lots of 4 to the half, 7 over 4 lots of 4 plus c, and now you just need to rearrange all that. I'm not going to bother doing that, the video's taking long enough as it is. So if you rearrange that, we get that c works out to be minus 84 over 5 apparently, and so my final answer then is fx is equal to 2/5 x to the 5 over 2 plus 5 lots of x to the half minus 7 over 4x, and then we actually know what this constant is, so minus 84 over 5, and then that's fx done. Just checking, yeah, didn't say anything about the way in which to show this, so yeah, relatively straightforward differentiation, well, not really differentiation, but more integration question and equations of tangents and normals. Hopefully that all makes sense to you.